Hello, my name is Oisin Boydell and I'm from CeADAR, which is the Centre for Applied Data Analytics Research, and I'm based at UCD. So firstly, data science. There's a lot of buzz around this topic, this term recently. So what is it exactly? Well, data science, you might hear big data, data analytics. There are all these terms that are kind of talked about a lot recently. And I suppose here's a number of just different definitions that might help to kind of clarify what these all mean and to show that they're really quite interrelated. So we see that we're talking about extracting knowledge or insight, large volumes of data here, extremely large data sets in another definition from Oxford English Dictionary, and we're looking at patterns, trends, associations, a valuable resource. And we're also looking at extracting meaning from raw data and to draw conclusions and identify patterns. So although these are different terms that are used a lot, they all kind of mean and refer to the same kind of general area, the same theme that is happening. So the first thing about data science and big data analytics, it's a very new area. And talking new, we're talking about the last 10 years, if that, where we can really process these really large volumes of data. And this is through the processing power and advancements, the cost coming down all the time, huge connectivity, and also the advanced algorithms which are allowing these volumes of data to be processed. And we're just at the beginning of the journey really here. So, I mean, if we think of what's happened so far with data analytics and big data, we're really just at the start. There's huge amounts still to come. And it's to think about this idea of the data-driven society, we're really just at the beginning of that journey. And there's a promise here to transform and disrupt. And I mean disrupt in a positive way in this case. So disrupt as in change for the better. Many aspects of society. So we're talking about society in general, industry, government, health, transport. And I suppose the idea of traditional decision making, which is kind of often based on hunches, best guesses, intuition, or who's the most senior person in the room. You know, maybe these are going to be seen outmoded and old-fashioned very soon. And this is already the case in many businesses where data-driven business where a boardroom decision is made, and if that's not backed up with evidence, with the data that drives that decision, then it's not going to be taken seriously. And I think we're going to see this a lot more in many different areas. So how does data science and big data analytics, how does this relate to sustainability? Well, data analytics and data science, it's been used right now to lower costs, improve efficiency, drive strategic decision making, and many of these other similar objectives across loads of different types of organizations and industries. And many of these objectives are often aligned with sustainability and environmental concerns, even if that is not the objective in themselves. So for example, lowering costs, well, this could be through using less energy or other resources, optimizing supply chains, and this does reduce waste and transport overhead. So often these objectives that are happening from a cost perspective are very aligned with sustainability and environmental concerns. And then of course there's direct objectives, and these could be to meet environmental legislation and sustainability targets directly using the power of analytics and data science. So I'm just going to talk about a number of case studies here of examples of different ways that data science is used in different ways from a sustainability point of view. So this company, Propeller Health, that are based in the US, they provide this quite simple device that turns a standard asthma inhaler that a huge proportion of people use every day into a smart device to help people manage their condition. So with a standard asthma inhaler, there's a little device that fits on the top of it. It connects via Bluetooth to your smartphone, and every time that the user needs to use that device, it records when that is, and also where it is through the GPS sensor on their phone. And the primary goal of this really is for that individual to manage their own condition. So they can see patterns of their use, they can see where this is, certain things that they were doing around this time. And that can help sufferers of asthma to really manage that condition and understand the kind of trigger factors for themselves. So this analysis of individual user data is for individual patient care. But what's more powerful here is when the data from many of such devices is aggregated, and it can offer a lot more. So there was a particular study trial done in Louisville in Kentucky, which is one of the cities in the US that has very poor air quality. And these inhaler sensors were used by local residents, so it was over a 13-month period, and they collected over 5,400 of these usage events recorded from the sensor, just from individual people using these to manage their own asthma. And this was then combined with socio-economic and environmental data to provide real-time air quality monitoring. So what this was able to produce is a real-time monitoring of the actual air quality within the area that these would be used. And of course this is huge benefits for environmental planning within that region. For example, to look at where you're going to site heavy industry, specific problematic areas that need to be looked at, also roadways and so on. It was actually more accurate and more fine-grained and ultimately more up-to-date data than that could be retrieved with standard surveys and other type approaches that are used. And it was also cheaper to deploy than dedicated air quality sensors. So there's a number of other cities that have actually deployed these air quality monitors around the city. But with this approach, this was done through, in fact, another purpose initially. And this is a kind of trend that we can see happening where data is being collected for some particular purpose, to provide a very useful purpose, in this case, helping individual people to manage their asthma. And then once the data is aggregated together and anonymized, of course, this can be used for much more diverse uses, and in this case, it's air quality management. So another case study to look at is the use of machine learning, which is an advanced analytics approach for home energy management. So there's statistics that space heating often accounts for the largest proportion of energy that's used in your home. And there's these number of these smart thermostat devices that are on the market, and these help people to use their heating systems more efficiently to save energy. And there's a number of these devices. I think that the one on the right here, Climote, is actually an Irish company that provides such a service. And these are little devices that sit on your wall. They sit instead of the kind of dumb thermostats that most people would have with their house. And they are connected in that they allow you to adjust your thermostat, your heating, manage that from your phone. When you're about to travel home, you can say, set your temperature that will come on, your house will be comfortable when you're at home. When you're away, there will be less heating usage because you can set that system. However, Nest, which is a company that produces these, which is now owned by Google, was the first widely adopted smart thermostat to use machine learning technology. Now this machine learning is quite an advanced data analytics approach. So it's an advanced predictive analytics whereby the system automatically learns from past data and behaviour to adapt and make new decisions. So what the Nest thermostat does is it learns automatically about your behaviours and how you set it, what times you're in and out of the house, what type of temperatures you like that's comfortable for you, and so on. And it automatically is able to optimise both the comfort for you and, more importantly, the energy usage. So it even has sensors, for example, that can monitor if people are using a particular room in your house, and if it learns over time that, okay, there's no one usually in this room during the daytime, then it can adapt your heating system so that you're not wasting energy heating a room that's no one's in. And over time, this can adapt to your usage patterns. And this shows another growing trend, which is the application of smart database technology to conserve and make more efficient use of energy and water and other resources at the end user consumer level. So what's going on here really is that, I mean, a lot of people are interested in more sustainable lifestyle, environmental concerns, but to make these continuous choices about how we live our lives and how we, for example, to remember to turn the lights off when we leave the house or adjust our heating schedule correctly, is an extra burden. And with these kind of technologies, this allows these kind of decisions to happen, to be adapted to people in the background, and people just want to get on with their lives. So this is an interesting trend, I think, in technology and these kind of smart data analytics-based approaches, kind of taking over a lot of that decision making to allow us to live more sustainably. And a final study is a nudge along project, which CeADAR, we actually did this as a project recently, and this is based around the idea of nudge theory. So this is an idea where it's a mixture of behavioural science and psychology, where we're looking at positive reinforcement and using indirect suggestion to try and achieve compliance, and it can influence motives, incentives and decision making of groups or individuals, and they say at least as effectively, if not more effectively, than direct instruction, legislation and enforcement. And this image here is actually of an example that's used a lot in this case, which is actually a urinal, where we have a fly that's etched in that urinal, and the idea here is it's a nudge theory, and when these are installed they actually produce much cleaner male washrooms, and there's way less splashback apparently, and that's an example of nudge theory in action that's often used. So getting a message across to people in order to try and change some aspect of behaviour, and this could be for sustainability or environmental objectives, it's challenging. So different people respond in different ways to different types of messaging. So for example, if you're trying to influence people to, for example, turn their heating down when they're not in the house, turn their lights off when they're not using those rooms, do you provide that person with an environmental message or maybe a financial message, how much money they could save by doing it? And different people respond in different ways to this different kind of messaging. Also, the different medium of delivery, how that message is delivered, and the different time even of the day when they might be most susceptible to taking heed of it. So with CeADAR's nudge-along technology, what this is an application of case-based reasoning, which is an approach that can automatically target the most appropriate message to the right person to achieve a specific objective. So in this technology, the technology automatically sends out various messages for a particular purpose, and we've done trials using this for this home heating scenario as well, where we automatically are generating these messages using these different kinds of messages that could be used, and the system automatically learns for different kinds of people based on the feedback which kind of message works best, and it can optimize that system to get the best results from what you're trying to achieve. And there's more information on web pages on CeADAR homepage about this and other projects that we've worked on in this area. So just a slide to basically introduce what CeADAR is. So we're the Centre for Applied Data Analytics Research. So we're an Enterprise Ireland supported technology centre, and we're based across UCC, UCD and DIT. And what we do, we focus on industry-driven, rapid turnaround prototypes and demonstrators. So our projects are generally 6 months in duration, which is, we feel, matches industry, the heartbeat of industry. All the projects we do are industry driven. That is, company partners that we work with come to us with particular problems. We don't do blue sky research. We don't do master's or PhD programs. It's all industry focused. We produce state-of-the-art reviews on different analytics technology tools and best practice and processes. And we have a thriving data analytics ecosystem, and we deliver seminars, conferences and members networking events. And more information can be found on our website, CeADAR.ie. Thank you very much.
just a quick question. I was interested in, the smart devices, for example, Plimote and the Nest one that are used in the local environment in the home. Are you finding that the analytics is done locally, or is that also being aggregated and then used? The data being used, does the data have a value at a sort of a larger aggregated scale to the likes of the energy companies and things like that?
Well, we find the case that a lot of companies producing these kind of devices, their initial concerns is with actually just, supplying that direct need to the user. So in the case of the smart thermostats, it's making your home more comfortable while reducing your bill that comes in every couple of months. And there's many companies that focus on that aspect of it. And I think there's a growing realization now that this data is more important, it's more valuable than just that individual approach, and this has been done more and more. And I suppose the Nest is a kind of example with that, because as Google have acquired that over the last couple of years, they're looking, I assume, to wider use of kind of gathering this kind of data. But I definitely think, there's these kind of two levels. So initially, it's a product on the individual level, but then, companies really should be looking at how this can be used in a more valuable way once a larger picture is being